This is lesson 2.6 on proving angles are congruent. So first of all, I just wanted to remind you of a couple of terms. A postulate is a true statement that's accepted as fact. It's assumed to be true. Whereas a theorem is a true statement that is proven true using deductive reasoning. Okay, so I kind of talked to you about this in the last lesson, but things that you're allowed to use when you're doing proofs. You can use the given information, you can use definitions, you can use postulates, properties, or other theorems that you've already learned, which you don't know a lot of theorems yet, but as we go through you'll learn more. The given information sometimes is actually stated as given in the problem. Other times it might be information that is deduced from the diagram. Such as two angles are a linear pair, or two angles are vertical and therefore congruent. Okay, we're going to prove the vertical angles theorem. The vertical angles theorem says that vertical angles are congruent. We talked about this back in the last chapter because we needed to use it before, but technically a theorem is supposed to be proven. So we have our given that 1 and 3 are vertical angles, and then we also are proving that they are congruent to each other. So you see over here our proof statement, so that we're proving that these vertical angles are congruent to each other. So our first statement is our given. Almost always the very first statement in a proof will be given information. Step 2 says that 1 and 2 are supplementary and 2 and 3 are supplementary. And we know that because they're linear pairs, and linear pairs are supplementary. Now our next step says that 1 and 2 measures add up to 180 degrees, and that the measure 2 plus measure 3 adds up to 180. And that is by the definition of supplementary angles, because since the angles are supplementary, they add up to 180 degrees. That's the meaning of the word supplementary. So we basically used step 1 to get step 2. We used step 2 to get step 3. And so we're really just looking how to get from 3 to 4. So from 3 to 4, what you should notice is on the left side we have measure 1 plus measure 2. And on the right side we have measure 2 plus measure 3, which came from the previous step. Why are they equal to each other? Well, they're equal because that 180 degrees there. So what is that called? Well, that's either transitive or it's substitution, property of equality. So basically now we've used step 3 to get to step 4. We're looking how to get from 4 to 5. Now notice that we have this measure of angle 2 that's the same on both sides, and that means that we can subtract the measure of angle 2 on both sides. So that's the subtraction property of equality. Okay, and then going from 5 to 6, well, remember that if you have the measure of angle 1 equals measure of angle 3, and you're going to them being congruent, that's the meaning of the word congruent. So it's the definition of congruence, or the definition of congruent angles. And we have proven that if 1 and 3 are vertical, then angle 1 is congruent to angle 3. So we've proven that vertical angles are congruent. Okay, so now we're going to use that idea in some diagram to solve some problems here. So we're using that vertical angles are congruent, and this is not anything new. You did this before. So we'd say 3x plus 50 equals 7x minus 10. So 4x equals 60, and x would be 15. It just asked us to solve for x, so we're finished after we get x. Now for the next problem, notice that we have angle 2 and angle 3 that are a linear pair. Linear pairs are supplementary, so we're not going to make them congruent. We're going to add them up to 180 degrees. So our equation would be 4x plus 11 and 3x plus 1 added together equals 180. So we have 7x plus 12 equals 180. So 7x equals 168. And 168 divided by 7 is 24. And again, on this problem, it just said solve for x. It didn't ask us to find the actual angle measures. There are going to be a few theorems in this lesson also. The first one is called the congruent supplements theorem. And it says if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So in this picture, we're saying that if angle 3 is supplementary to angle 1, so let's say angle 3 is 150 degrees, that would force angle 1 to be 30 degrees. And if angle 2 is also supplementary to angle 1, then it would have to be 150 degrees also. And then, therefore, that makes these two angles the same measure. So if then form it goes, if angle 1 is supplementary to angle 3, and angle 1 is supplementary to angle 2, then what's the conclusion? You're going to want to say that 1 supplementary to 3 and 1 supplementary to 2 would make 2 and 3 supplementary, because you're thinking transitive property. But it doesn't work like that. So the result is going to be that angle 3 is congruent to angle 2. And again, you want to think about the picture here. So if you have angle 1 is congruent or supplementary to angle 3, and angle 1 is also supplementary to angle 2, then that forces angle 2 and angle 3 to be the same measure. That forces them to be congruent, not supplementary. Now, the same idea happens with complements, right? So if you have two angles that are complements of the same angle or of congruent angles, then those two angles will also be congruent. So again, if you had complements, let's say that 1 and 2 are complements, so let's say 2 is 50 degrees, and that would make angle 140 because they're complements. And if 3 and 2 are also complements, that would force angle 3 to be 40, and therefore you would conclude that angle 1 and 3 are congruent. So it would say if 1 and 2 are complementary, and 3 and 2 are complementary, then 1 and 3 are congruent. Not complementary, congruent. Just like up here, not supplementary, congruent. And again, these are called the congruent supplements theorem and the congruent complements theorem. So lastly here, we have two last theorems. And this is a theorem because it can be proven, but it's kind of common sense. All right angles are congruent. Since their measures are 90, that's going to mean they all have the same measure, so they're all congruent. And then the last theorem here says, theorem 2.5 says if two angles are congruent and supplementary, then that makes them each right angles. It's kind of written down here. If two angles are congruent and supplementary, then each is a right angle. So if 1 and 2 are congruent and they're supplements, they're going to have to add to 180 and they're the same. That's going to force them to be right angles. So angle 1 and angle 2 are both right angles. So these are kind of common sense theorems. Again, they're theorems because they can be proven, but they're not anything that doesn't sort of make sense. So you can use any of these if you're doing a proof involving right angles or congruent supplementary angles. This is the end of this lesson.